Hello everybody, I'm your host Hywel Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello to all our listeners out there and welcome to today's episode of the Space Industry Podcast by satsearch. Today I have a special guest for you guys. I'm speaking with Jatan Mehta from Jatan Space, a website and a series of newsletters and articles that Jatan produces and on all different topics and primarily around the moon, lunar exploration, lunar missions and planetary sciences, and as well as space in India, focusing on the government missions and the progress of the country, which is a topic that's very close to our hearts on satsearch. And yeah, I'm hoping to get into a lot of this work today to discuss the different aspects, the different opinions and insights that Jatan could provide us with. Hi, welcome to the podcast. Great to have you here.
Yeah, thanks, Howell. Thanks a lot for having me here. It's exciting.
No problems. I wanted to begin with planetary science. You write regularly on a number of topics in the space industry, as I just mentioned. I do have a range of questions for you in this interview, but yeah, let's start with planetary science. Now, what do you think has been some of the most important activities and events in this area over the last few years?
So there's a lot going on in planetary science, especially in the last decade, both with missions that are active and missions that are on their way to their object that they are most interested in, that scientists are most interested in studying. So there's, of course, Perseverance from NASA, which has been completely studying the Jezero crater in depth over the last 2-3 years with its whole suite of instruments. And there's, of course, Curiosity, which is also ongoing strongly. At the same time, there's Juno from NASA, which is studying Jupiter and its moons. And most recently, it gave us fantastic views of the most volcanic moon in the entire solar system. In fact, the most volcanic place in the entire solar system, which has a lot of implications for studying the Jupiter system in general. And of course, we also got some great views and a lot of good spectrometer data from Ganymede when Juno made its close passes to that moon, and that's very interesting. But at the same time, on the other side, there are missions being planned to Venus, although we don't have an active mission yet, apart from the Japanese orbiter that's in a very long elliptical orbit. But we don't have an active mission that's trying to do a full mapping of the planet, even though it's very important to study because Venus tells us a lot about how Earth evolved. And there are gaps in the understanding of Earth's evolution that we are not able to fill if we do not understand Venus well, right? And Venus also gives us a lot. It will give us insights a lot about into exoplanets because a lot of these exoplanets that we have found that we are banding together under the term Earth-like, and not really Earth-like as much as they are Earth and Venus. So there's a whole range of Earth to Venus-like exoplanets for which also we need to understand Venus. And that's where the next interesting set of upcoming missions come into the picture. So you have India's Shukrayan mission, which is not yet completely commissioned, but it's about to be. And so we can expect that to be launching before end of decade to map Venus at one of the highest resolutions to date. There's also Envision from ESA, which recently got the green light. And so that's going to happen for sure. And it's, I believe, going to launch somewhere around 2031 with the next, when there's the launch window for it. And that's also going to be collaborating with one of the NASA Venus missions. And also there's some collaboration with the ISRO Venus mission so that together they can do a complementary job of understanding the dynamics at play in both the Venus's atmosphere and also the surface. So that's really exciting, at least in my opinion. And then, of course, when we talk about planetary exploration, there's also lunar exploration because if you think about it, lunar exploration is how planetary exploration started, right? Because the first time we had the capability of sending spacecraft beyond Earth and to other objects, the moon was the first destination that we targeted. back in the space age. And of course, then we sent robotic explorers, followed by Apollo astronauts. And it's really like the planetary science as a discipline really came into the picture uh, from lunar science. So, as such, we also need to include lunar science, where, of course, as we know, there's a lot happening other than Chandrayaan 3 and Slim and intuitive machines, Odysseus landers having soft landed on the moon and helping us get science data from the surface from areas that we had not been before. There's also the upcoming missions which are equally exciting, which are going to target the poles of the moon. You have the Artemis missions, the Artemis crewed missions in particular that will be landing somewhere around 85 to 90 south. They haven't decided yet as to where the exact landing zone is going to be, but that is the region that they are targeting. And all of them have one thing in common, which is water ice. So all of them host water ice in permanently shadowed regions, which is very important for multiple reasons, for both from a technology point of view, long-term habitat point of view to use that water ice for consumption, let's say, and also from a science point of view, because the way that water ice got there is via comets and asteroids, right? And bombarding the surface of the moon. And that tells us not just about the moon's history, but also about the solar system's history. So going there and accessing the nature or like accessing that water ice and studying its nature gives us a window into the solar system that we never had before. And there are likewise robotic missions going from ISRO and JAXA, called one of them is the LUPEX mission that will try to study this and tell us more about it. So yeah, basically bottom line is that we have this whole range of missions studying the right from the inner solar system to the outer solar system. And then there's also the one thing I did not mention is the kind of mission which is the Osiris Apex mission. So after Osiris Rex from NASA gave us samples from the Bennu asteroid, now it has been repurposed to study another asteroid, and that's why it's been renamed Osiris Apex. So that's going to be an exciting extended mission phase where you are just getting more and more bounty of science from something that you originally paid much less for. So that's really exciting. At the same time, samples from Bennu are here on Earth, and NASA recently quantified them to be about double the amount that they had originally expected. So that's amazing. And of course, we are expecting Mars sample return soon from a host of missions, including Japan's MMX mission, which is about to launch in 2026, if I remember correctly. And then there's also the Mars sample return from NASA end of decade, and then there's one from China. So yeah, there's a lot.
Yeah, absolutely. Thank you very much. I think it's a bit of a masterclass in current and previous and upcoming planetary science missions there. I really like the way you contextualize these different things, explaining that the importance of our work and understanding, for example, Venus in terms of both the early years of the Earth, but the exoplanets that we're out there tracking. And yeah, all of these future missions are opportunities as well for increasingly for private companies to test and prove out different aspects of their technology as well, which could have knock-on effects in the industry. And I think that's particularly true with the lunar missions because there's been such a renewed focus on this over the last few years. And this is an area you focus on a lot as well. You write Moon Monday, I think the world's only newsletter dedicated to lunar exploration and updates from different places around the world. So there are lots of missions and programs underway. You've mentioned some of them, and these are very well publicized. And but also a whole lot of technical issues remain. I think we've seen this with intuitive machines with the number of the recent missions. And sometimes if you listen to commentary from a little bit outside the industry or dare I say, those people who are trying to raise investment for different parts of the industry. It seems like a crewed colony on the moon is imminent. But yeah, as I say, every real mission shows us the technical challenges we face are still there. In your view, what do you think are the likely next steps in lunar exploration? Not based on the mission announcements, what people are claiming that they're going to do, but on actual technical feasibility. We've got the chance of a lunar space station, a surface base, the a GNSS, lunar GNSS, or lunar PS, whatever LPS, whatever you call it, constellation to facilitate these things, lunar internet, satellite internet, and then obviously crewed missions. What do you think are likely to be the order that we're going to see these things really achieved out there?
Yeah, that's a really great question because I think, as you rightly pointed out, technical feasibility and the reality that we're dealing with right now with the moon missions and the state of them is really important to consider at the end of the day because we can only plan so much, but the execution is really tough. Because let's just say that despite modern robotic landers being better off in terms of their computing capability and ability to recognize features on the moon while they are descending, and so on. Even then, if you look at it, our success rate for lunar missions at the time of this recording is basically 50% in the last 5 years, right? So, despite all of these missions from many countries with many capabilities, we still have a 50% success rate. And so, while that's obviously not negative for sure, and we can certainly improve on that, but at the same time, it's not wholly positive either. So, which means that challenges remain in our ability to land reliably on the moon. So that's one thing to solve first and foremost before we even think about doing bigger things. So that's one. But once you do solve that, and I do believe we will solve that in a few years, it's not like it's completely out of reach. So once you do solve that, then there's the next step, which is related to water ice, in my opinion. There's a lot of these plans and the vision for lunar settlement and the lunar economy and so on and so forth, an Artemis program also, and programs of many other countries in general, they all bank on the fact that you have water ice on the south pole of the moon, which they assume would be accessible in some form or the other, more or less readily, right? But that's something that we do not know yet for sure, because all of our understanding of it is based on orbital data at this moment in time, which is not incorrect, but at the same time, it's very coarse and there could be false positives, right? For example, a radar could tell you there is a water ice sheet in permanently shadowed regions on the moon, but certain rock types could also register the same signature, which means that the only way we would know is to actually go there and find out for real if it's water ice or not, and if it is really water ice, in what form is it? Is it binded to other lunar soil, or is it clean water ice sheets, or binded to some other molecule, or whatever else? So basically, to your question, the first thing that we would need to do after being able to reliably land is to go there, to go to the true South Polar regions where there's actually potential water ice deposits, or at least some water ice deposit for sure, and then have a rover go there, scoop the soil or drill into the soil, and then try to figure out using its spectrometers and other means as to how much water does it actually contain and what state is it in. And the good news is that we do have at least a couple of missions, at least three missions planned to do exactly that. So Intuitive Machines, who recently half soft landed on the moon, let's just say that, the next mission also has NASA as the anchor customer for the CRIPS flight, and NASA is flying one of the Honeybee robotics provided drills on them. And the next mission is going to go to the extreme south pole. So IM-2 will drill on the moon and then try to analyze the scooped out sample for water ice. So that's one. Second, there's the ISRO-JAXA collaboration mission called the LUPEX, which is basically a large 300 kilogram rover being delivered on a large lander sometime before end of decade. And this rover will try to go inside permanently shadowed regions, scoop samples, and also have a radar to tell where we are likely to find water ice locally, which we have no idea of based on orbital data, and then try to study that water ice to understand its exact chemistry and state. Similarly, there's the NASA Viper mission, which was originally supposed to be delivered end of year from Astrobotic, but because of Astrobotic's failure with their first CLIPS mission, I think it would get delayed a bit. We are not sure yet how much at the moment, but nevertheless, it's a mission that's planned and they will do it at some point for sure. So Viper is similar to Lupex, and it will also try to go inside permanently shadowed regions to understand water ice. That's the next set of missions that we have. Once we do have that understanding, at least a rough understanding of what water ice on the moon really looks like, then we can send crewed missions. which are also on the roadmap, at least for NASA and China. Oh, I should also say at this point that China has a similar mission to Lupex and Viper also planned with Changi 7 and 8 in particular. So Changi 7 will tentatively launch in 2026. Changi 8 will launch in 2028, and they will give China information about water ice in the polar regions as well, based on which they will send the next set of missions. So once you have this information, you send crewed missions because you can't really send crewed missions blindly into these regions. There's a lot of risk. The temperatures are insanely low. We are talking about cryogenic temperatures, right? We are talking minus 200 degrees centigrade to minus 250. That's the range of temperatures that exist in permanently shadowed regions. Even with protective spacesuits, you do not have a lot of time to yourself within those regions. Sending crewed missions is extremely risky in those regions. So you would only do that after you have some certainty from robotic missions. So that's what we'll get next in terms of the roadmap. Artemis and Chinese missions will do that end of decade, let's say. And in terms of realistic timelines, I'm not going by the NASA suggested timeline of Artemis 3 being in 2026 because, in my opinion, it's not realistic. There's a lot of engineering challenges and also scientific challenges that need to be solved. So I would peg it as near end of decade in the most optimistic scenario. But there's the space station from NASA, or at least the NASA-led space station, rather, where you have most of the same players which are there at the International Space Station, sans Russia. Okay, so you have NASA, you have the Canadian Space Agency, you have the European Space Agency, you also have the Japanese Space Agency, and most recently, it's also the UAE Space Agency that joined the project. So the project is called Gateway, and it's a small lunar orbital station that's planned and that's set to be launched end of next year if everything goes well in its most minimal form, where you just have a habitat module and a power and propulsion module, and then you can extend it later. So that's an international project which is very exciting because before sending humans to the moon, we can certainly send astronauts there, and that's relatively low risk. And that gives us a ton of info about not just our hardware, but also about the radiation environment at the moon. Because other than the Apollo missions, which were short lived, the International Space Station doesn't tell you anything about the deep space radiation environment because it's within the protective magnetic field of Earth, right? We are just, it's just like 400 kilometers above the surface. So Gateway will tell you real deep space radiation environment information, which is critical not just for lunar missions and that we hope to be long lived in the future if we ever want a habitat there, but not just lunar, but also Martian missions because the deep space radiation environment won't change drastically if you're in lunar orbit versus let's say in Martian orbit, right? So that's a key piece of information that we can get before even landing astronauts on the moon. So that's something that we can expect sooner.
Wow, fantastic! Thank you. That's a really, really great overview of what's upcoming in the lunar exploration, and it's really interesting to see how all these missions will play out and what's likely, what's going to happen next. And what do you think about the development of a lunar economy that could arise as a result of these missions and others? If we look at things more from the commercial sector.
Yeah, I would take the relatively non-popular view here. I do not think there's a proper lunar economy burgeoning just yet, despite the narrative of, for example, the Eclipse landings being commercial and whatnot. But if you really look at their anchor customers, it's basically NASA at the moment, right? For most of the flights, for all of the flights, actually, at least a major customer, the anchor one, is NASA. And then you have some spread of truly commercial customers in some small capacity. However, it would be too, at the same time, it would be not wise to judge this too quickly because even NASA knows they are the anchor customer yet. What they are really trying to do is act as a catalyst. And once, let's say, you have a handful of, let's say, at least half a dozen to a dozen CLIPS missions, and then which gives the landers a chance to really increase the probability of their success in future missions, then you can start thinking of having more commercial customers. But at the same time, there's a tangent available here which if you look at iSpace Japan, it to me it stands out as different from the bunch of Eclipse vendors because you have iSpace Japan is not a US company, and they send their first mission mostly from their own funding sources via various series of investments from diversified sources. And if you look at their payloads that they had as customers on board, you had the Rashid rover from the UAE Space Agency. You had three payloads from the Canadian Space Agency, not exactly from the Canadian Space Agency, but from Canadian companies who were funded by the Canadian Space Agency to develop those payloads, indirectly the Canadian Space Agency. So these are the two main payloads they had on board, and that's interesting because I think in that way it can be considered commercial because neither Canada nor the UAE have the ability to go to the moon indigenously, right? Because indigenous launch vehicle capabilities, satellite bus capabilities, and all of the things that need to come before being able to send an indigenous spacecraft to the moon do not exist in those two countries, right? But at the same time, they do have the ability to develop certain payloads. For example, Canada does fantastic in robotics and instrumentation. So why do they need to even develop indigenous capabilities if they can just send their payloads on someone else's flight, right? In that sense, it was commercial. And if you look at it that way, then there are ample opportunities. In fact, Astrobotic also carried several small payloads from other countries who do not otherwise have space capabilities. So I think we'll get there eventually, but it would not be right to call them commercial just yet because based on if you just do the math for where the majority of the money is coming from, it's not commercial at the moment.
Okay, yeah, that's a great, that's an important point. I think like I said, we have to tread a fine line between optimism, excitement, and hype in the space industry. And lunar missions can be one area where this is blurry. So I think that's a really clear, explanation of it there. Thank you. Now, last year you mentioned this. The Chandrayaan 3 mission resulted in India becoming just the fourth country to land on the moon. And you write a lot as well, as I mentioned in the intro, about the space program in India too. So I wondered if you could give our listeners a bit of an overview of where things stand and what's next for the country. Maybe people from other countries are not as familiar with the space program there, although I guess that's changing a lot in the last few years because of the successes that the Israel has had.
Yeah, there's a lot going on in India as well with regards to space. I think, let's see, in terms of the most high level points, there's of course the Chandrayaan 3 and the aftermath of it. Because of Chandrayaan 3's success, which was really important on the world stage, because otherwise, sans the Chinese, no one was really able to land on the moon before Chandrayaan 3 robotically, right? In the recent years, that is obviously. And we had these failures after failures. So Chandrayaan 3 was an excellent boost both within India and outside. And what that has done for India in particular is that the government of India in late last year announced that they have this vision now of sending an Indian to the moon by 2040. Of course, it's an ambitious goal. We probably might miss the 2040 timeline. But nevertheless, the point is that they have this goal in the first place now, which was never there before. And the intent of it was never there before. And to meet that goal, the government of India is now going to successively sanction an increasingly complex series of Chandrayaan missions. So the first of them is the LUPEX lander, which we already talked about, the LUPEX lander and rover, right? So that's the first of those missions. Then we also have a sample return mission planned, which will be tentatively called Chandrayaan 4, but it's not done deal yet. So there's a sample return mission that India is planning, which would be not dissimilar to Changi 5. So that's one thing. And if they pull that off, it would be amazing because other than the US, the Soviet Union, the former Soviet Union, and China, nobody else has done a sample return from the moon ever. So that's one. And then basically what you're seeing is that if you look at these increasing capabilities, you are building up to the necessary technology required for crewed moon landings, right? And so India, what they hope is that with these series of missions, they would have crewed capability for not just Earth orbit, uh, but also to the moon eventually. And they hope to be part of the Artemis program because India last year signed the Artemis Accords, and they have every intention of collaborating with the US and its partner countries to see what their contributions can be. Like, for example, India is considering providing some sort of a technology to the gateway, which can in return get us an astronaut to be there at the gateway once it's built. At the same time, coming back closer to Earth, before we even think about sending humans to the moon, of course, we need to send humans to Earth orbit first. And there also, it's only the US, the Soviet Union, and China who have achieved the feat so far. But we are fast getting there because in 2018, the government of India sanctioned the Gaganyaan project, which whose aim is to send at least two Indians to Earth orbit on a fully indigenous basis. You develop the launch vehicle on your own, you develop the spacecraft on your own and all of its modules and so on and so forth. So India wants to indigenously send humans to Earth orbit. And most recently, there was a bot test flight conducted for that to that end. Parallelly, we certified the launcher for that mission to be human rated. So that's a whole process of testing every component of your rocket, doing multiple engine firings and so on and so forth. So it's a huge process to human rate the vehicle because, of course, the moment you put humans inside a space capsule, the criteria for success and the risk, everything changes. We obviously value human life a lot more. In general, the level of confidence required in your vehicle have to be really high. India recently completed that multiple year process of human rating the entire launch vehicle Mark III rocket, which is currently the most powerful that we have in India. And that's the same rocket, by the way, which launched Chandrayaan 3. And that's the same rocket which launched the OneWeb satellites last year. Two sets of OneWeb satellites. Yes, yes. So that's the same rocket, right? So there's a lot going on there. But at the same time, we are also planning a Venus mission, as I said, and then there's also a follow-up Mars mission being planned because the last time we went to Mars was in 2014. We demonstrated the ability to enter Mars orbit. But this time they are thinking about landing as well. A Mars lander might be in the mix, although it's not commissioned just yet. So there's still time for that to manifest itself. At the same time, there's also a small but important element where you have this focus on growing indigenous space technology capabilities. For example, we have these set of satellites providing regional GNSS services, right? So that's a indigenous capability called NAVIC that we have. Um, it's navigation by Indian constellation. And right now it's in a very, very basic state where regional navigation works, but they want to be able to expand that. And so for that, we are planning four more satellites to be launched in the next 2 years, which will expand the capabilities. And it will also have the capability to interoperate with other GNSS systems, which will really increase their utility while also bringing the cost down to end users. So that's one interesting area. At the same time, there is the upcoming project called the NGLV, a next generation launch vehicle. And it's a partially reusable launch vehicle, which is currently in the PDR stage. So it's in the preliminary design review stage. I'm not sure if it has passed it or not. The information is a bit murky on that, at least publicly. But the idea is that we really want to have a much more powerful vehicle that's also reusable so that the costs can be reduced and also we can have more indigenous capabilities at the same time. And that will also feed forward into having a human space station in Earth orbit because we cannot pull that off with the existing launch vehicles, at least not easily. And that will also be necessary for our increasingly complex Chandrayaan missions that we spoke of. Because if we ever hope to send a human to the moon, we cannot do it with this launcher that we have. And so, with that in mind, this new rocket is under development. It will take time, but it will be worth it.
Okay, brilliant. Yeah, like you say, a lot going on. I've seen a couple of announcements. Sorry, go ahead.
Yeah, yeah. So I just forgot to say that since there's a lot going on, so I would highly suggest at least your listeners to tune into my website. And there's a section called Indian Space Progress. So it's a monthly newsletter that I write where I try to basically cover everything that's going on in Indian space every month. So that gives you a bird's eye view of the progress of Indian space, as the name suggests. And there's also, of course, there's one thing I forgot to mention is that there's also progress on the space science front. We launched our first space telescope in 2015. It was called AstroSat, which is still ongoing and giving excellent data. And we got some 150 plus peer-reviewed international publications out of it. So that's a pretty good first mission, I would say. But at the same time, we recently launched the first solar telescope from India called Aditya L1. It has begun its observations from the Earth's on L1 point. So that's exciting. We expect to have some great results to show next year from that and also late this year. And we also recently launched ExpoSat, which is like it's a small space telescope. It was launched on January 1 of this year. And its sole purpose is to study highly energetic cosmic objects like black holes and neutron stars, and specifically their X-rays. In that sense, it's a very focused mission, but it is going to give you data at a resolution that no other telescope in the world has. So for that specific purpose, it will be really nice. And it will also, one of its goals is to collaborate with NASA's similar space telescope called the IXPE so that the community can benefit from that collaboration and really understand these certain cosmic objects better. So that's also going on at the same time.
Great. Yeah. So, yeah, progress in the research area as well. Thank you. And just to say, we will link up your newsletter and website in the show notes for this episode so that the audience can find you there and find out more. So thank you for that. Yeah, I was just going to mention a couple of announcements I've seen this week, and we try and keep track of the global industry. I'm sure it's going to be limited, but the first astronaut crew, I believe, have been named, and also an announcement on breaking ground on a new spaceport in India as well. So yeah, lots going on all the time. And we touched on it, but
Oh yeah, I totally forgot that. Thanks a lot for that mention.
yeah, just in the last few days at the time of recording, not the time that we're going to publish the podcast. And I'm sure there'll be more by the time we publish the podcast too. So yeah, it's important. Lots of things to keep track of. So we've talked about various areas that you are on which you write regularly. Now, and all of this, as I understand, is carried out independently. And you've written for publications. I've seen Scientific American, Nature, Planetary Society as well. And I can see from the introductions you've given us to, or the updates on planetary science that you've given us there, that obviously this is a writing that requires a high level of research and detail there. So, how does this writing process, this independent space writing process, work for you? I wondered if you could, share some thoughts and ideas for budding science writers out there.
Yeah. So I think it was a process for me to figure out as to how I would go about these things. But it started off as so my background is in physics. I did my master's in physics and subsequently I studied astrophysics. I did some astrophysics research for a year, but I also had this passion of writing a blog about space from everything cool that I learned from studying physics. And at some point that caught on and caught the attention of a space company here in India. And they asked me if I would like to write about the science and tech about their space stuff that they are developing. And I said yes. And that's when I realized that I really like writing about space exploration. And I would like to convert this into a full-time profession and not do academic research. And then I started figuring out as to how this might work. And after attending a few conferences and following certain people online and reading their blogs, I figured out that basically, if you want to become a freelance science writer on covering any field, not just space, but also space, what you have to do is either create videos and podcasts. Of course, that's one option. But if you want to write in particular, what you have to do is you have to contact editors of various media publications and pitch them your article ideas and your capabilities and why you think you are an expert to speak about this subject. And then they may or may not accept the pitch. Whoever does, you write for them and you get paid for it in return because publications are looking to commission articles to freelancers all the time. Every publication has a certain budget and you can write for various publications. You get paid for it. But of course, the most important thing here is that you learn a lot in the process from the editors as to how to write for a large public audience, which is not something you learn in your, especially if you are from an academic space, hardcore space tech or science background. So that's one point. And the other thing is you get more visibility and credibility for your writing. And so you start iterating on this process, right? So you write for one publication, then the other, and then slowly you write for publications which are, so to speak, at the top. and then you can go from there. So by doing this process, so I started writing for national publications at first. I wrote about Indian space missions and Indian space media publications, and that gave me visibility, reach, and some credibility. And then with that portfolio, I could show to the foreign publications that this is what I've written and this is what I can do. And then they assigned me articles to write about Indian space for them. And subsequently, they assigned me articles to write about, NASA space missions as well, because it's not just limited to Indian space that I can cover. So that happened. And then slowly, because of these experiences, I realized that I started getting some editorial instincts myself, because when you work with so many people, you start to absorb some of their traits, right? So I started getting some editorial instincts myself, and then I thought lunar exploration is an up and coming thing. There's so many missions planned, and we are looking at a resurgence of sending humans to the moon alongside many robotic missions from around the world. And but nobody's doing that, nobody's covering that dedicatedly. So maybe I should. And that's how the idea of Moon Monday came into being. And so I started after trying to ask a few people in the industry as to what do you think this idea sounds like. If I write this sort of a thing, will everyone read every week, or will there be enough news every week? And then I just started it, and the reception has been amazing. So once I had some sort of an audience, then just like every other newsletter, tech newsletter in the industry, I could go around and find sponsors for that. So I have a few organizations sponsoring Moon Monday, so that's how I sustain the business. So that's one. And similarly, I have a few sponsors for the Indian Space Progress newsletter that I mentioned earlier. And then I, of course, continue to write for media publications. This is broadly how the process works. With my own blog and newsletters, I have full independence to write what I want. And then you have sponsors taking the sponsors, and also reader donations taking some of the support, doing some of the support for that. And then you write for other publications as well, depending on if you want to reach your audience or if you want to reach a broader audience.
Excellent, thank you. I think that's a great overview for anybody out there who's interested in finding their niche in the space industry and would like to build a career as a communicator in it. That's great, thank you. And as I say, we'll share links in the show notes. I've covered pretty much every area that I was interested in asking you about today, Jatan. But finally, I think aside from the things you've covered, and you have covered a lot in terms of the planetary science, the lunar exploration, the progress of the Indian space program, but feel free to look outside of those areas where you write about a lot, or if there are things in them you'd like to talk more about or you haven't mentioned. But I wondered what you were most looking forward to in the space industry over the next few years.
I think I already mentioned it, but I will just allude to it again that more than anything, I just want to see a rover go inside a permanently shadowed region and scoop the sample and tell us what it really is like, because that's a big unknown right now. And not just in terms of exploration, but also in terms of science. And if you look at this, okay, maybe I'll expand a bit, which I didn't earlier on this particular point. Other than the water ice being very interesting in terms of both technology and the science of the past of the solar system, to figure out the history of the solar system and its evolution, there's another aspect, which is the same south polar region where you expect water ice, you also expect certain other materials. For example, you expect lunar scientists expect chunks of mantle material from when the moon formed. So if you see all the lunar samples that the Apollo missions bought, some 382 kilograms of rock and soil samples is what Apollo missions gave us, and that is amazing, right? That completely changed everything we understood about not just the moon but also the solar system. But it does not have mantle material in it. It only has crustal material in it. So the mantle is deeper, and so we there are many unknowns about how exactly the moon formed and evolved. And not just that, because the Earth's history is tied to the moon, because the moon is thought to have formed from the Earth's mantle itself, because of a collision with a Mars-sized object 4.5 billion years ago. So unraveling what really happened to the moon is also unraveling what really happened to Earth. So there are chunks of mantle material expected to be scattered in the larger South Polar region. where these many of these missions are expected to go, both robotic and crewed. And so at least some of them, or at least one of them, are likely to come across these materials. And one of, at least with the Artemis crewed missions, they do have a goal of trying to sample this material explicitly. So when they do and bring it back to Earth, and we study it with all of these excellent, sophisticated laboratories that we have on Earth, which we can't really compactify and send on these mass constrained missions, then we will get to know so much science that we did not before, and I'm sure it will change our like completely overall our understanding of the moon for good, and also of the Earth and the solar system at large. So I'm really excited about that.
Fantastic. That was a very specific answer. I wasn't quite expecting that. So that's great. Thank you. But yeah, when you've laid it out like that, the importance of the understanding this material, this information, and you've already explained the context in terms of the use of water ice for future missions and future uh, facilities and technologies on the moon's surface, as well as understanding from the planetary science perspective. I think, that makes a lot of sense. So thank you so much for sharing that and sharing all of the insights and information with us today. It's been a really great conversation. Thank you.
No, thank you. Thanks a lot for having me here. It was truly exciting.
Great, thank you. And to all our listeners out there, thank you very much to you too for spending time with us today on the Space Industry Podcast. We'll share, like I said, show notes about everything that we've discussed today, links where you can find out more, sign up for Jatan's newsletters and website, etc. And please, as always, if you like the conversation, go to your favorite podcast player, give us a rating, honest rating and review if you can. It helps the algorithms spread the word to more people in the industry where we'd like to share this information with. And please stay tuned for the next episode of the Space Industry Podcast by satsearch to talk about more of the companies, organizations and people who are taking us all into orbit. Thank you. Thank you for listening to this episode of The Space Industry by satsearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.